Everything around us is made of elements. From the air we breathe to the ground we walk on, elements are the building blocks of our universe. Some elements, like oxygen and carbon, are abundant and essential for life. Others, like gold and platinum, are prized for their rarity and beauty. The value of an element depends on several factors. Scarcity plays a major role. The rarer an element, the higher its price tag. Practical uses also drive demand. Elements crucial for technology, medicine, or industry often command high prices. But some elements are both rare and relatively useless, making their value more theoretical than practical. These elements are scientific curiosities, fascinating for what they reveal about the nature of matter. In this exploration, we'll delve into the world of the most expensive element, uncovering the science and stories behind its extraordinary value. When we talk about the most expensive element, we're often referring to the cost of producing a single gram of that element in its pure form. This cost reflects the difficulty of isolating the element from its natural sources, which can be incredibly challenging for rare elements. Elements are formed through various processes, from the Big Bang to the deaths of stars. Some elements are naturally abundant on Earth, while others exist only in trace amounts. The distribution of elements is a result of billions of years of cosmic events. The rarest elements are often those with short half-lives, meaning they decay quickly into other elements. This radioactive decay makes them difficult to study and even more challenging. The most expensive element on Earth is francium. Discovered in 1939 by Marguerite Perey, a French physicist, francium is a highly radioactive element with a fleeting existence. Its most stable isotope, francium-223, has a half-life of just 22 minutes. This means that every 22 minutes, half of any given sample of francium-223 will decay into other elements. This rapid decay makes francium incredibly difficult to study or use in any practical applications. In fact, no weighable quantity of francium has ever been isolated. Francium's rarity stems from its position on the periodic table. It is the heaviest known alkali metal, residing at the bottom of the first column. Elements in this group are highly reactive, readily forming compounds with other elements. Francium's chemical properties are similar to those of other alkali metals, such as sodium and potassium. It is expected to be a soft, silvery-white metal with a low melting point. However, its intense radioactivity makes it extremely difficult to handle or study. Due to its short half-life, francium exists only in minuscule quantities in nature. It is produced naturally in trace amounts through the radioactive decay of uranium and thorium. Even in controlled laboratory settings, producing and studying francium remains a formidable challenge. Scientists estimate that at any given time, there is less than an ounce of francium present in the Earth's crust. This extreme rarity contributes to its astronomical price. Section 5. A collaborative discovery. The discovery of francium is a testament to the collaborative nature of scientific progress. Marguerite Perey, working at the Curie Institute in Paris, was studying the decay products of actinium, a radioactive element. She noticed a faint radioactivity that could not be attributed to any known element. Perey meticulously isolated and analyzed this unknown substance, ultimately identifying it as element 87, the missing alkali metal predicted by Dmitri Mendeleev's periodic table. Her discovery was a significant milestone in nuclear physics and solidified the predictive power of the periodic table. Perey initially proposed the name cation for the new element, reflecting its positive charge as an ion. However, she later settled on francium in honor of her homeland, France. Section 6. The challenges of study. Studying francium is a race against time. Its rapid decay makes it impossible to observe its properties directly. Scientists rely on sophisticated techniques, such as laser trapping and spectroscopy, to study francium atoms for brief moments before they decay. These experiments provide valuable insights into the structure of francium's atom and its interactions with other elements. However, much about francium's chemistry and potential applications remains unknown due to the challenges of working with such a short-lived element. Despite the difficulties, scientists continue to investigate francium, driven by the pursuit of fundamental knowledge and the potential for Section 7. Potential, not practicality. While francium has no current practical applications, its unique properties hold promise for future research. Its intense radioactivity makes it a potential candidate for medical imaging and cancer therapy. In theory, francium isotopes could be used to target and destroy cancerous cells with high precision. However, the challenges of producing and delivering francium in a controlled manner remain significant obstacles to its medical application. Francium's primary value lies in its contribution to our understanding of the universe's fundamental building blocks. Its study provides insights into nuclear physics, radioactive decay, and the behavior of matter at extreme. Section 8. Francium in perspective. The price of francium is often cited as being in the millions or even billions of dollars per gram. However, it's important to note that this is a theoretical cost based on the estimated expense of producing it. No one has ever purchased a gram of francium, nor is there likely to be a market for it. Francium's value is not measured in dollars and cents, but in its scientific significance. It represents the cutting edge of our understanding of matter. Section 9. A universe of value. The story of francium highlights the diverse and fascinating nature of elements. While some elements are essential for life and industry, others, like francium, challenge our understanding of the universe's fundamental building blocks. The pursuit of knowledge, driven by curiosity and a thirst for discovery, is what makes elements like francium so valuable. Their rarity and fleeting existence remind us of the vastness and mystery of the cosmos, urging us to continue exploring the wonders of the natural